So today we're looking at a question from the 2010 exam, AB number 3. This is a rate and accumulation problem, so we're going to be looking at rates and integrating them to get total accumulation. In this problem we're looking at people standing in a line at an amusement park. The ride accepts passengers until the park closes 8 hours later. While there is a line, people move on the ride at a rate of 800 people per hour. That's a useful rate. The graph shows the rate at which people arrive at the ride throughout the day. Time t is measured in hours. So starting off, we have 1,000 people per hour joining the line. 2 hours later, it climbs up to 1,200 people per hour. And in part A, they ask how many people arrive between time 0 and time 3. So we know that integrating a rate function will give us total accumulation. So if we integrate r of t from 0 to 3, it'll tell us the total number of people that have arrived at the ride. Now there's a couple ways we can do this. One person might be inclined to count squares, in which case I've got 1, 2, 3, 4 times 3, that's 12 squares, 13 squares, 14, 15, 16 squares, and each square is 200 units by 1 unit. So 16 by 200 gives you a total of 3,200 people. So in the 3 hours, 3,200 people have joined the line to ride. Another person might break it down into a trapezoid plus another trapezoid. So if you're in favor of the trapezoids, our first trapezoid is 1,000 on the left and 1,200 on the right with a width of 2 units. And our second trapezoid is 1,200 on the left and 800 on the right with a width of 1 unit. Now, both of these approaches yield the same answer of 3,200 people. So there are, of course, probably other ways we could break up the space into rectangles and triangles, but this gets us there. Part A is worth 2 points. The first point comes from writing the integral expression that leads to the answer, and then the second point comes from answering what was the total accumulation of people into the line. All right. Let's look at part B. Is the number of people waiting in line to get on the ride increasing or decreasing between time 2 and 3? Justify your answer. So this takes looking at 2 facts. First, people move onto the ride at a rate of 800 people per hour. So basically every hour 800 people are getting out of the line and hopping onto the amusement ride. Over here on the graph, between the hours of hour 2 and hour 3, we are gaining anywhere between 1,200 and 800 people adding to the line. So if more than 800 people are getting into the queue or into the line, but we're losing 800, the number of people is increasing. So the number of people waiting is increasing. And the reason for that is because r of t is greater than 800 on the interval 2 to 3. So the rate of people jumping in line is faster or is more than the rate of people leaving the line, at least in that interval, time 2 to 3.
Childcare and other social issues facing the average family.
Whoop! Looks like I got her calibrated a little bit too high.
This part is worth 1 point. So the correct answer with justification gets you the 1 point. Part C, at what time is the ride line the longest? And this one's going to take 2 different approaches. We can rationalize our way through it, or we could actually set up an equation that models the number of people in the line and then maximize that. So I'm going to take that approach. It's a little more mathematical than the second approach, but the number of people in the line at any given time is equal to, well, we started with 700 people in the line at the beginning, and to that we are accumulating 0 to t of our rate function of people being added to the line, and from that we are losing 800 people per hour getting onto the ride. So this tells us the total number of people at any given time t. And if they're asking when is the ride the longest, we are going to be looking for when is n maximized. So we have to find n prime of t, and we get r of t minus 800 if we take the derivative of both sides. N will be maximized at a critical value. The critical value occurs when r of t equals 800. So our max or our minimum occurs at time 3, and this is at t equals 3. Prior to time 3, n prime of t, prior to time 3, sorry, n of t is going to be, n of t is increasing and then decreasing with that transition at time 3 because the derivative is positive and then negative. Okay? So we know that we've reached a maximum at that point. So the ride is longest at time 3. The ride line is longest at t equals 3. And if we want to know how many people are in there, well, we've already integrated from 0 to 3, so we'll have 700 plus the 1600 minus 2400 people in the line. Sorry, correction, 700 plus 3200 from part A minus 2400 people. So 7 and 32 minus 24 is, which equals 1300 people are in line. Okay. Double check we've answered all that at what time? Time 3. How many people in the line? Here, and then our justification is found within the work. This part is worth 3 points. You get 1 point if you identify t equals 3 as a candidate, 1 point if you are able to deduce how many people are in line, and then 1 point for the justification. And the justification, we used the first derivative test for local extrema. On to part D. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time at which there is no longer a line for the ride. Well, fortunately, because of the work that we did in part C, we already have an equation that tells us the number of people in the line. I started with 700, and then I accumulated from time 0 to t the rate that people are adding onto the line, and then I lost 800 people to the ride every hour. So this tells us the total number of people in the line, and it says write but do not solve an integral expression that gives the earliest time where there's no longer a line for the ride. So the number of people in the line would be 0. So this is the equation for what they are asking for. And we do not need to solve that. We just need to write down the expression. This is worth 3 points. You get 1 point for the integral 1 point if you accounted for the 800t, and then 1 point if overall you have an equation that does the expression they're looking for, +1, +1, +1. All right, total 9 points. Thanks for watching. Ask good questions, conquer the world.